So we are in the fourth lecture of software engineering, and we're discussing these different types of association, right? We talked about, it's a little bit, I always find it confusing that that the association has its own, like really there's no such thing as association. There's either aggregation or composition. And association is sort of a broad category, which includes aggregation and composition. But it's not really true because they're, like you see from this diagram, you can draw association as that has its own way of drawing it. So if you're not, I guess if you're not being specific about how the connection is, you draw an association. If you want to be specific, we talked about aggregation and composition, which relates to the life of the intertwining of the life of the length of life of the two objects. And here's this example. Let me do view, present. Okay, so we have an example of composition where a person is composed of a brain, a heart, and legs, in the sense that if a person dies, his brain doesn't continue living and his heart doesn't continue living. I mean, in most cases, and his legs don't continue living. In other words, their lives are intertwined, even though he's composed of these things and they're separate things, but presumably he holds the, he created them and he'll delete them when he dies. Of course, it doesn't have to be that way. And then we have multiplicity. For example, a person may have not one leg, but two legs. How would you show that? So you can write 2. You can write, like over here, you'd write a number 2. Or you could write, like, legs also can only be associated with one person. The legs can't be associated with several people. So you'd write 1 to 2. But that would be exactly 2. You might want to have at least one leg. I mean, people could have no legs, actually. You could theoretically have 0, ... 2. A person could have 0 to 2 legs. So that's what this means. You can have disjointed ranges where you have like 2 to 4 or 6 to 8. But you can't have 5 or something. Okay. And then there's inheritance, which you're probably all familiar with. Inheritance is also referred to as specialization or even generalization, which kind of, depending how you look at it. In other words, the parent is a generalized version of a specialized version of the child. Child is specialization because, in other words, animal might be your class, and then dog is a certain kind of animal. He has certain characteristics. He has a heart and lungs like an animal, but he has also other things. So again, that's the idea that the parent or the child inherits attributes from the father and methods from the father. So that everything that is true, this is a good sentence, everything that is true about the about the parent is also true about the child. If the parent can do a certain functionality, then the child inherits it. He can also do that functionality, but he can do extra functionality or has extra attributes. And here's an example. So we can have a document which has in it all these characteristics. Now you're going to have to make a class diagram for your project. So understand how this looks. This means that this is the way you're going to do it. That the author, that this means that there's a string which is called author, and the minus sign. Well, did we explain that already, or we're going to explain it? I guess we already explained it. So you recall that the minus sign means that it's private. And the date is private. But there's a function called getDate, which is public, which allows me to access it, right? We have this concept, this is a general concept in programming where you have these private methods. Sorry, just checking something. You have these private attributes. Generally, you want the attributes to be kind of private. Almost always, they should all be private. And you should have like these gateway functions that serve as a gateway that manage your access to these attributes so that somebody can't put in an impossible date, February 30th. You know, you may not want to just let them set this date. Well, date type, the type itself should prevent that. But you may not want them to change the date of a document. It may be that when it was created, that's it. You can't change the date. So you want to make it private, but you want to be able to have access to it. So you have a get date, and you can also have a set date theoretically. So that's in general rule of programming. You probably heard, if you heard that before, Jonathan, you know that rule that you basically don't, all of your data is private. And then you have a function called get authors, which returns something of type string. Notice it's an array of strings because it's get authors. There might be multiple. And then a book, well, a book has title, but it also has author, date, get author, get. It has all these same things. It also has a title, though. Not every document has a title, but every book does. And an email also has an author and a date, but it also has a subject line and a to line. So these are specializations of the generalization document. Now we have something called a realization. What UML calls a realization is created in Java using an interface. That's what I recall. And it is created in C++ by using a pure virtual class. I'm not sure if only a pure virtual, maybe a virtual class also is. Well, really a pure virtual class, right? What is a realization? Does everyone remember what a realization is? It's what an interface is. Did you learn Java? In other
we
words,
have a course in Java at the moment.
At the moment, right. How's that going?
Okay, pretty well.
All right, good. So yeah, so in Java, you have something called an interface, which is it basically means like you define the functionality that you want everybody who inherits from you to implement, but you don't define how to do it. You just say, I want a function that's called get, get average, or get string, whatever it's called, whatever function you have. And each individual implementation of your whoever inherits your interface must, by force, define how to do that. In other words, the functions are just like signatures, and you have to fill them in anybody who inherits from them. That's the same as a pure virtual class. In other words, the class's functions are completely unwritten, and therefore the person who inherits from them will have to do that. The parent class says nothing about how the implementation should be done. He just says what he wants, what the function should do. So here's a realization example. Person realizes owner. Owner is an interface, and he has a function called acquire property and dispose of property. And he'll have to, you don't write it here, but he'll have to actually implement these things. Anyway, the point is you write it instead of, if we did before with a solid line, here we do with a dotted line. Okay. Now we're on to a new topic, which you haven't learned before.
All right, I have a small question regarding interfaces. It's just something I haven't seen before, but why exactly, can we have a data member in our interface and say, you have a function which uses the data member? Why is it that we don't necessarily have data members in our in an interface? Is it possible, you know? I guess I could check. I'll just write it in chat.
I'm not sure. I'm not sure. If you can have data there. I think theoretically you could. I don't see why not. It would still be an interface, even if you had data, because you still wouldn't be able to create an instance of it until you wrote the functions, right? I'm not sure. You can check that out. It's been actually a long time since I have programmed using these things. Right? Anyway, I don't remember exactly. Realization. So okay. So, but it's a good question, but definitely worth looking up. So now we're on to the second half of this lecture, which is sequence diagrams. So use cases show how the system will be used. Class diagrams show what elements will be used to build the system. So the sequence diagram shows the order in which the elements of the system interact to provide the use cases, to provide the system behavior. In other words, how are these classes going to achieve the results that the use cases say they should? Because the class diagram doesn't say how they work together exactly. It says this one has that, and that one has this, and this one has an us. But how do they use each other? In what way? It also shows what sequence of events each use case will trigger in the system. It's an interaction. It is an interaction diagram. In other words, it shows interactions between classes. The other two interaction diagrams in UML are communication diagrams and timing diagrams, but sequence diagrams are more popular. So we'll do those. So did we do activity diagrams? I think we did, but anyway, let's look at this. Let me just see where we're going.
What's the activity diagram?
Activity diagram is kind of like a flow chart.
Is that where you like see like this creates that?
Wait a second. With these, remember, it's like a flow chart. It's with these question, should I do this? Then I do this, then I do that. We had swim lanes. If you remember, we did swim lanes. It's more, it's even more detailed, I would say, than the sequence diagram. Right? It shows the beginning of a process and the end of a process. It doesn't actually have classes. It just has what to do here. It's more detailed. I would say it's more detailed. And I did say that, and I do say that. Okay, so view, present. Okay, so we're back to sequence diagrams. And here's a nice picture of a sequence diagram. I didn't make this diagram, but I curated it. I looked for a good one that I thought was useful. Hard actually to find a good example. It was hard. But here we have we have a listener called navigation listener, and he's waiting for a hyperlink update event, right? So I guess some kind of event. Somebody clicked on something or something. Yeah, somebody requested a page or something like that. And he's listening for that. He's just sitting there waiting until that event happens. This is a class. And then what he does is he calls the page loader to actually, I guess, load some page to run. Then once he's loaded the page, the next action that the navigator, that the listener does is he runs the page. Now, what does this line here mean? This line means here, how long is he active? Is he like part of the process? He started working here and he ends working here. He only starts here, the page loader. I mean, you could draw this, by the way, you could draw this up above, but I don't know why it's drawn like this. It could have been drawn up above and then this go to the line. I guess he loads the page, but do you want to show that it's not active yet? See here, he goes to the line. Now, once he's running, he is going to call the browser.
Could it be that he created the page loader was only created?
Instantiated it.
This, right, instantiated in this action.
Mm-hmm. Okay, yeah, I take
Looks
that.
like the top three already exist and they're just being called, whereas this one maybe.
All right, excellent. I hadn't, that's, you're probably right. You're probably right. I guess you're right. I mean, I don't have anything, I can't think of anything better, so I guess you're right. So here, the browser, here I mean, I don't even understand exactly what's going on here. Maybe one of you understands better, but you know, somehow they're loading a page. I mean, I chose this example, but I couldn't find a better example. So anyway, you activate the browser. Now the browser is doing something, and now the Java editor pane, JEditor pane, I guess you set in the pane, you have to fill it in with the text. So that's the job of the page loader. So he sets the text, and then he's working to do that. And then he finishes, he goes back, and then he goes back, and then he goes back, and it comes back to the, and I guess the process finishes. So basically, we're just basically trying to load, doing a very simple thing, which is just load a page, a web page in Java.
This diagram has two different kinds of arrows. Are they, do you know the difference?
Yes, these are return. These are return arrows. They're not activation arrows. They're finish
forward ones as well, like for hyperlink update. It also has like a not filled in arrow.
This one?
Yeah, whereas run has a full arrow. I'm wondering if they're.
Yeah, I see what you're saying. I see what you're saying. That is a good question. I don't know. You see here, they're all filled in. You see, normally it has this little create thing on it. But maybe it doesn't have to if it goes directly to the class. Maybe that's enough. You know, the truth is UML is supposed to define these things exactly. So, but maybe the example I have didn't follow the thing. Maybe it's supposed to say.
No, the top two arrows, it shows what the difference is.
Oh, you're right. There you go. Synchronous message, asynchronous message. A synchronous message means that the sender waits for the recipient to finish before continuing. And asynchronous means that he does not wait. This is a very important concept in general because it appears in many different contexts, synchronous and asynchronous. And it always means pretty much this. In other words, synchronous means, well, synchronous literally means with a clock. Syn is like Greek for with, and chronos is Greek for time, with a or clock. So it means with a clock. Asynchronous means it's without a clock. In other words, I do it, I don't wait. So that means I have no idea if I'm gonna just keep going, and you're gonna do whatever I asked you to do will be done at some point. I don't know. Here, I am not gonna budge until you finish. So that means if I'm on to my next stage, it's synchronized with you because I know that you've finished. So there you go, synchronous and asynchronous. So if we go back to our picture, I mean, I guess this picture I wasn't really intending to explain everything, just to show you the general idea. So here, wait, what was it? So the hyperlink just asks the listener to start. He doesn't like wait, or he doesn't have to wait for that. And he asked the page loader to do this thing. Well, that's kind of weird that that's asynchronous because he can't run it until it exists. So I don't know exactly how you can run something if you maybe didn't create it. There's no create. Well, maybe that's what this, I don't know. Maybe he did create it, maybe he didn't create it, I'm not sure. But you get the general idea. Let's go into more detail. That example really only makes sense if you really are in the world of Java and you know how to do websites in Java and things like that. What does a sequence diagram show? You can use a class diagram. So here's I quoted from this guy. So you write like this. You can use a class diagram to illustrate the relationship between the classes. Okay, that makes sense. And the sequence diagrams lets you show the messages sent among the instances of the classes and the order in which those messages are sent. And when an object sends a message to another object, it implies that the two classes must have a relationship that must be shown in a class diagram. So in other words, there has to be some kind of consistency. If he is calling this, is sending a message to page loader, then he must have a pointer to that guy, right? He must have a pointer to him, or some kind of pointer, or an instance of him, or something. He's got to have some relationship. When you want to model the interactions between objects in runtime, with the sequence of method invocation, in other words, to show when our function's being called, you can make use of a sequence diagram. While a class in a class diagram represents a blueprint of data, a lifeline in a sequence diagram represents the instance of such a blueprint, right? In other words, this instance is existing for this time, and it may be finished, it may be killed, it may be deleted at this point. It's no longer alive. We're showing a life, this is called a lifeline. Literally a lifeline, it's a line that shows the life, as opposed to a normal lifeline, which is like when when you fall off a boat, they throw you a lifeline, or when you're underwater, they have a tube that gives you air. That's a lifeline. How to show objects. So we write, so over here, we write the class name. Indicates a class. Object, so this is a little bit weird because like there's different ways of doing this. One thing I'm not sure of is when to use this and when to use this. So this indicates an object of the class. This is the most usual way to show objects. So in other words, we're normally going to write the object name and the class name. In other words, the instance name. What if we have an instance? This is something that always bothers me with class diagrams, because you show the relationship between the classes, but you don't show what the instances are, like how do the instances relate to each other? I mean, you do kind of with multiplicity, but here we're actually going to refer, here we're going to actually refer to an instance of the class. And here we indicate an unnamed object of the type class name. So in other words, we just didn't write anything before the semicolon. Here we just said a class, and here we said a class, but we wrote a colon here. And that means that really there's an instance here, but we're not giving it a name. So I'm not exactly sure when you're supposed to give it a name and when you're not supposed to give it a name. In other words, like, do we have a name for it? Yeah, you have to think about it. You have to get your head around that question. I'm not sure. But anyway, I wrote that this is the most usual way to do it. Comments. You can write a comment in this little symbol like that. Send a message, maybe like describing the message. You may have like a message that's sent, but there's no comments here. What does page loader do? You might want to make a comment. Sending a message creates an interaction. That sounds reasonable. Message, participant. See, this doesn't mean it's got created at this point. It's already created, like Jonathan said. This just means it's active now. It's doing something. And here I have a comment. Send, what did I say? Send, receive, right? He said, it's kind of a dumb comment. But just for illustrative purposes, it's good. Messages, you may be more familiar with the term signals or events. So messages are, right. I'm saying that it's like a signal or event, but Well, it's not really a signal or an event because those sort of conjure up the idea of like a hardware event or a mouse click, but they could be, after an if, I just call a function. So that's not really an event, but that's why we call it a message. The term signal is usually used to refer to software-generated interrupts, whereas term event usually refers to hardware-generated interrupts. Both signals and events come under the umbrella term messages. But, well, this is thinking in terms of a real-time system, which is governed by signals and events. But our system is not going to be a real-time system. It's going to be an information system. So these terms, these terms are less meaningful. But we're going to think of it as a function call, really. So message, arguments, and he finishes. What is this? This is the message caller activation bar, right? He's activated. The message itself. The return arrow is optional. In other words, you don't really have to have that return arrow because once the box finishes, he obviously returned. The signature of the function. The class participant. See here, this is a participant class. I don't know here why we didn't write that. See, this kind of violates the rule that I just said. Here we have participant 2, but here, for some reason, we didn't write the class name, but maybe just to save space. Should have been written participant class. So we have 2 participants that are talking to each other. Can anybody think of an example of where you'd have such a thing?
A participant?
Yeah, well, it's just the name of a class. For example, a string might run a function on another string to see if it's a substring of it, right? I may have one string may have a pointer to another string, and he wants to check if the other string is a substring of itself. My string is happy birthday, and this string is birthday. So I want to check. I'm going to have a pointer to birthday, and they're both objects of the type string. And see what I'm saying? They're instances of the same class, but they're communicating with each other when I want to find out if happy birthday, if this string that he's pointed to is already contained within him. So he would run a function called, check if, substring. And he has to have a pointer to that class. And then I don't know what exactly this class is doing. This class is maybe returning him his string, his content. Right? He could be returning the content of himself. Because it's like calling a get, Anyway, that would be 2 classes interacting with each other. How to define messages? How to define a message? Do something. You can do it in different ways. You can, you write the signature, just the way the function would be. Here is with no parameters. Here is with 2 parameters, both of the same class. And here is with a return. Here's do something with no parameters. And here is, what is that? Oh, here the my variable attribute in the message caller is assigned the value of the object returned. So you could get more detailed. You could do that, or you could just do like this. This message returns an object. In other words, it returns an object of type return class. You see, there's a return class. But they don't write the word return class. You write the name of the class that it returns. And here you have a message that takes parameters. So you see messages are really just functions. The vertical dotted lifeline coming down from an object indicates time and the life of the object. When the object when it receives a message, it is activated. Then the dotted line changes to a vertical rectangle. This indicates the object has received a message and is now doing some action. So actually the whole lifeline, it's not dead here. It didn't die here. It's still alive, but it returned, the function returned. Right. Nested message. So here, okay. nested messages. So this is not so complicated. We saw this already. But essentially, he sends a message, and then while he's doing that, he sends another message and another message. So these are like nested inside of this message, inside of this event. It's almost like a nested activity. It's a function, a nested function call, really. Again, this diagramming is really designed for real-time systems, but it's more useful. So here we have the asynchronous and synchronous. We have create and destroy. You see, you just put an X on the lifeline, and that shows that its lifeline is over. But then who did the destroy? When implementation will be in Java, destroy messages are unnecessary. There's no destroy. Return messages are optional. Example of asynchronous and synchronous messages. So here we have asynchronous. And then while this is going on, see, this is a very good example because he's showing while this is going on, he's still sending some other message to here, waiting for him to return, and then here. So he was active while this was active. So therefore, this must have been a asynchronous call. Participant creation and destruction messages. So that's what I said. You just send to his lifeline, ends early here. And here you created him. So here you see a create without going to the box. Here you see a create going to the box. How can a create be, how can he exist? It does seem to be better like this, makes more sense. This does seem a little bit weird because his lifeline started before he was created. Okay. Examples. Sorry, I'm keep moving the picture around. Example of use case and sequence diagram for the same system, creating a blog account. So here's this use case, create a new blog account. So he's going to check identity. Sometimes he'll record application failure. Here he'll always create an identity. Author credential database. That's an external from our system. So that's why it's drawn like that. And then create a new regular blog account. These are create a new editorial blog account, different versions. Okay. So here we have the actor, the administrator, and he is creating a new blog account, and he's calling. Here we didn't see that. We saw we will see content management system. So that's being translated as a class, on a kind of some overarching class that has in it the whole system. That it is responsible really for the life of all the other items, I would assume. Author credential database. So he creates a new blog account, creates a blog account type. Check author details. So he does. So the author credential database is activated for that check. Create new regular blog account. He does to it himself. This is all the content management system. He activates something internally. Send email notification to the email system. Okay. So you see, it gives a little bit more detail, but not as much as the activity diagram. So that's the end. That's the end of lecture 5.
How does this actually look where like a company's using this? Like we're only seeing like a really tiny bit of it. Like
you're right. I also was trying to find a good example of like a real system that actually does something. Whereas this is
I feel like
very,
it just gets super massive. Like you can have, if you're using like hundreds of objects, then you would have like all 100 objects, or would you like split it up? Like each time you need to do a new sub thing, then you'll have like a new diagram or whatever.
you're right. You would have to describe a very small part of your system or a very broad overview of your system, right? Could be very broad, or it could be just a subsection of your system. You're right. You can't possibly do everything here. The same with a flowchart, with the activity, the activity diagrams like a flowchart. What are you gonna do? A flowchart for every single thing? You'd have to have many flowcharts. Probably have to have many activity diagrams or sequence diagrams also. But what I'm trying to show here is that for a particular use case, which there might be 8 or 10 of them, you could write, each one will get its own activity diagram. I mean, its own sequence diagram. That's what we're trying to show here, that you'll make a sequence diagram for every one of the use cases. Now, a use case is every way you'll use the system. So you're defining all of the things the system does in terms of classes that are used and how they're used. But it's in pretty broad strokes. I mean, we're not saying how the functions internally work. Okay, now we're in lecture 6 already. Architecture. This is like system architecture. So now, okay. I don't know, have you guys heard of this MVC? All right, so this is very important. I would say this is, even though a lot of the lab and exam are going to, a lot of the lab and the exam are going to be based on what we've already done. This is actually pretty useful stuff and important stuff, more so I would say, than what we did up to now, in my humble opinion. Okay, so wait, all right. So how does this, so, I don't know why I just jump right in here. How does the 3-tier architecture different from MVC? Oh, I guess the slides got it in the wrong order.
Did we
maybe
did we talk about the 3-tier architecture?
I don't think so. No, we didn't. I don't think we did. Did we talk about that? No, I think the slides.
Probably thinking about it from a different class.
I think I must have switched the order of the slides. So now I just changed the order. Let's see if this makes more sense. With the 3-tier architecture, you have layers with different responsibilities. Okay, in other words, we're talking about architecture, software architecture, how to build software in a reasonable way. Now, in other words, you guys are used to writing software that like 2 people write, or 1 person writes, or maybe 4 people write. But what if you have we're really talking about places where they have software that's written by 500 people. How you have to have a pretty good design of your architecture. You have to divide it up. You have to figure out what the different sections of it are. So this becomes this huge topic called, like, that's what we're doing in this class, kind of software design. In other words, for large scale software. So we're going to start off with this 3-tiered architecture. With the 3-tiered architecture, you have layers with different responsibilities. The user services, or services in general. This layer is more about coordinating the retrieval and modification of the model layer. Complex multi-step actions get performed here. So in other words, this is like the layer that the user will use, it provides all the interactions for the how to use the system. But then there's a business layer. This represents the business rules etched into programming code, what the business wants to enforce in this layer. In other words, we may have certain, if think of an example, we may not want to let a certain
It's the logic of the program.
Right. In other words, if a rule might, right, as simple as that, a rule might be, you know, the gross product, the gross, you know, revenue of the company is computed in this and this and this way, right? You don't compute the gross revenue another way. This is the only way. You're not going to let anybody modify that, right? That's how you compute the gross revenue for this company. So that's like the business layer. Or, you know, if it's a library, you know, this is the procedure for buying a book. We're not going to let any client, you know, client of the library buy a book. Only certain people can buy the book. We have a certain set procedure. Then there's the data access layer. One or more classes responsible for accessing a persistent data store. So, right, usually you don't directly. It's interesting. I don't know which slide to put first because here I'm mentioning MVC here. Usually you don't directly access your data. You know, you could directly access your database by, you know, SQL commands, but a lot of times you're going to have classes that their job is to do that. Where did I go? I don't know. I have to figure out the order here. The only part of the three-tiered architecture that intersects with MVC is the business layer. The models in MVC and the business layer in three-tier architecture are trying to achieve the same goal. So let's go. Maybe I should have started with here. Here's what Greg Berghard says about, on Stack Overflow. And as I ask the question, how does the three-tier differ from the MVC? This is like asking, what's the difference between an apple and an apple core? These two architectures aren't replacements for one another. I think the more accurate view is the three-tiered architecture augments MVC. So a lot of times people will say this, which, you know, you can use the three-tier or the MVC, and he's saying, they're really complementary. So what is the MVC? So maybe this is actually the first slide. The MVC is called Model View Control. Should be a comma there. I don't know. Model View Control, I guess. I don't know. So models, these represent the stuff in your application. This layer has gotten a little fuzzy in recent years. I'll explain later. Views, the user interface, the things the user interacts with. In other words, the model you could think of as like your database. You know, what actual information do you have? And then the idea of the view is the view shows you, presents that data to the user, presents whatever data you want to show him. And therefore, you could keep the same model and change the view. If you have a layer called the view layer, I can change it without having to directly change the models. Now, the models may not be the database. They may be classes that represent the database. But the idea is that there's some underlying data model. This is like a data model. And the view is how to present it. And the controller is the program code that responds to the user and changes the model layer. In other words, in the view, I can say, I want to change something. So I change it. Then the controller layer will actually go and change the data. You know, my birthday isn't December, it's January. So I'll do that. In the view, I will request that, I will make that change. the controller's job will be then to access the model, the actual data. That's the idea of model view control. And I want to change that. So then we should discuss the 3-tier. Is more about coordinating retrieval and modifications of the model layer that we saw before. You know, just like, it's like a different, yeah, I don't know exactly what the 3-tier is so much. The M in MVC has gotten fuzzy. The model layer in MVC has expanded in recent years. From what I've seen, there are two or possibly three kinds of models. In other words, you can have there's 3 different kinds of models. So we have a business model, but let's domain models. These represent the things that the business cares about, the business domain. These classes hold data and all procedures that operate on the data. In other words, holds the data. That's what I was saying, the database. And all the procedures that operate on the data in order to enforce those rules. In other words, you know, I can change how much money we charge for a certain item, but I can't change how we compute our you know, our total revenue. So there are some functions that are associated with the database that are model level, because if you want to change them, you'd have to change the model. In other words, if now we are counting, you know, donations as revenue. You know, we weren't counting donations, now we are. So we're gonna have to change the model. So it's not only so the model is not only the actual design of the database, it also includes rules for manipulating the data. Frequently, domain models are tied to tables in a database. Right. This seems to fit the business layer of the 3-tiered architecture. View models. These are another kind of model. These are classes used to massage the data from the domain models into something more palatable to the viewer. In other words, we may store our gross revenue in, like, you know, to the last, you know, cent. But when we show it, we may want to show it in thousands. You know what I mean? It may be a large number. We may want to display it in a different way. But that's a kind of model also, because it's a rule about how we're going to show the data. But it's a view model. This doesn't fit anywhere in the 3-tier architecture because view models do not implement basic business logic. In other words, there's no rule that says in business you have to display this revenue in thousands. You could display it however you want, but it's a view rule. It's a rule that is how our system wants to display things. Nor do they provide any sort of service or data. Okay, right. So in other words, this is missing from the 3-tier. In other words, the 3-tier architecture wouldn't relate to this type of function. And then we have business models. In complex applications, the need to decouple the domain model from the business logic arises. The business models contain data and procedures operating on the data to implement business rules. And the domain models are relegated to property bags, objects that just hold data but contain no behavior. Domain models become another form of a data transfer object between the database and the application. In other words, in large systems, you can turn the domain model into pure just accessing of the database, just classes which enable I don't know if you, there's an environment called Magenta, which does this. You cannot, I mean, you could access directly the database, but the main way of accessing the database is through classes. You know, when you update a certain class, it updates the database automatically. And that gives you, see, databases are not object-oriented, but classes are. So that gives you a way of relating to a database in a class, in an object-oriented way. But you know, you don't want in the middle of your code an SQL query. It's ugly. You want to deal with the database through classes. So you're going to need your data model. But what's saying here is that you might decouple the data model from the rules about how to compute things. Like I said about the how to compute gross revenues. So if you do decouple them, if you disconnect them, then you'll call those things the business model. You'll call those functions the business model, and the domain model will just be the actual classes for storing the data. It'll be more simple. Okay. Nowhere in MVC is data access mentioned. In other words, how exactly to access the data. In some cases, you'll see the data access belongs in the model layer. Well, that's what I was saying, which, as we've seen, is not a clear-cut layer anymore, right? Because it could be that there's this business layer. Really, I see three-tier architecture being paired with MVC to create a whole application. One augments or improves upon the other. So we have these models, which are domain models, the view models, and the business models. And then we have all the models, and the models are basically data models. But here, how to view the data, how to manipulate the data, and how to store the data. Then we have the views, how to view the data. And then we have the controllers, how to modify, you know, how we'll limit the way we modify the data. We're not going to allow direct access to the data model. The controller will allow us to control the data. And then we can put on top of that the data access and the services from the three-tier. All right, it's a little bit in the air because we're not familiar. We are not, you know, you guys have not worked for 15 years as programmers in companies. But if you would work for 15 years, then you would more relate to this. Okay. So now I'm going to talk about another kind of architecture, service-oriented architecture. The biggest difference between service-oriented architecture and client-server is the coupling between the tiers. So what do I mean? In service-oriented architecture, the server side is very independent of the client. Many different client types use the same server. And this is also a big thing. This is the whole concept of services. Oh, here I'm quoting from this guy, Rob Conkle. This is from Stack Overflow. But you see, architecture can be, what does it mean service oriented? It means that I just want to have services. I will have, let's say, theoretically, almost a different server, different machines that will provide me a service. And if I want to get that service, I'll do like an HTTP connection to that server with a certain string, a certain, you know, line in my HTTP connection. And because I wrote that line, he's going to give me a certain response, as opposed to a different response. If I wanted a different, you know, whatever service I want, I'll give, you know, essentially I may have a server that all it does, to make it simple, all it does is add numbers. So it's an add server. So or, you know, I could have one server that does add or subtract, and I can send it add, I'll do HTTP, the IP of the server, colon, and then the word add, and then 2 and 3. And then he'll return me the result. So you could view that as that's client server, right? I'm a client getting a service from a server. That's a client server relationship. But client server is usually when like there's a lot of stuff on the client, on the server, a lot of things that he can do for me. And my whole program essentially is, on the server maybe, and I'm accessing it through my client. But here what we're saying is, no, let's turn the servers into just like, almost like individual function providers. And I'm still on my side going to do stuff with the results that I get. So is the coupling between the tiers. In server-oriented architecture, the server side is very independent of the client. In other words, I just know how to do my add and my subtract and calculate the distance from here to the nearest star or whatever, I just do my things. Whatever you want, I'll give you that service. Many different client types use the same server. As you could be Windows, you could be as long as you give me an HTTP, string with the right format, then I'll service you. It does the same thing no matter what browser you use to connect to it. In this way, the service-oriented architecture services are designed for reuse, because if I change my whole architecture, if I change my operating system, I can still use the server. Client server, on the other hand, is usually more coupled. There is a connection. If I change the server, if I change the client, I've got to change the server. The server exists for a specific client. In other words, you can't access, I don't know, maybe this is not true, but you can't access, let's say, Google Docs with a non-Google browser. I mean, it's not really true, I don't think, but the point is, you could have a service that a server provides that it needs a certain client to be there. Without planning, so think about, so here's a better example. Microsoft's Exchange, that's their mail service. It is designed only to work with Microsoft email clients. You can't access an Exchange server with some other email client. You have to have a Microsoft email client accessing your email server. It is literally just splitting a single process into two parts. In other words, running them on different machines. Some of it is written on the client and some is written on the server. That's server-client architecture. As opposed to service-oriented, I view the server as a service that it provides. That being said, technically, a service-oriented service is a client server, right? It is technically a client server, but it's just with more than one client or independent. The architectures are in other words, there's no deep coupling between the working of the two. So all service-oriented architecture services are client-server, but not all client-server processes are service-oriented architecture. Right? Is that clear? Is that clear? I think. Are any questions? That's a bad thing to say. Is that clear? But I understood what I said. So at least one person understood. Okay. For example, say you wrote a calculator in C++, which performs 4 operations: add, subtract, multiply, and divide. You can deploy this code on a server. That's exactly what I was saying before. Now you want to publish this code on the internet so that any person in the world who has a connection to the internet can use your code. You can create a web service based what you are running on your server. I don't know. A web service based on, well, I guess on what you are running on your server. If you're using a Apache Access server and you have implemented your code using JAX-WS or Java API for which is a Java API for XML web services. I don't know if you know XML. XML is exactly this idea that you send an HTML request in a certain format so you can get a certain result. And your code will be published as a web service on a URL like www.myservercalculator. Should have a .com there or something. Now, how are you going to access this service?
API.
Yeah, it's an API. You can make a website called calculation.com, which takes two integers, inputs two integer inputs, and calls your web service using something like this: my server calculation add for addition and subtract for subtraction. In other words, I have another website which will use my server to get the calculation. Now, each of your web service operations, addition, subtraction, multiplication, is working as a service. If in the future you have a requirement to make an equation solving service on your website, you can reuse your addition, subtraction, multiplication, and division web services using those links to make a new service. In other words, it's essentially like writing a function, but it's a function that runs on a server and that you can access it in a uniform way, independent of your architect, of your operating system or your architecture or your software. Here you have achieved service-oriented architecture. Okay. So we discussed briefly, kind of, we're going to discuss it more, I think. MVP, we discussed this 3-tier a little bit. We discussed service-oriented architecture. Now, let's discuss another topic. Enterprise resource planning. This is a major thing. This is more like business. Is an integrated management of main business processes, often in real time and mediated by software and technology. In other words, it's basically software to help you manage your business. ERP is usually referred to as a category of business management software, typically a suite of integrated applications that an organization can use to collect, store, manage, and interpret data from many business activities. In other words, it lets them keep track of their salaries of their workers, of their sales, of their expenses, basically to manage the whole company. Enterprise, the whole enterprise, resource planning, because people are resources, money is resource. ERP provides an integrated and continuous updated view of core business processes using common database maintained by a database management system. In other words, I can check at any minute, how much money I'm making today. If I want to know how much money I made today, or how much money I made this hour, or how many sales are happening in the past hour, I can keep track of all what my company is doing. ERP systems track business resources. That's why they're called resource planning. What are resources? Cash, raw materials, production capacity, factories, and also employees, and the status of business commitments, orders, purchase orders. In other words, I've ordered something, has it arrived? Payroll, the application that makes up the system applications share data across various departments, manufacturing, purchasing, that provide the data. ERP facilitates information flow between all business functions and manages connections to outside stakeholders, right? So outside people can, investors can see how much money they made, how much money the company made the past month. I want to know if you're screwing up the business. That's ERP. And then there's something else called CRM. I don't know if these terms I hope that these terms have sort of like, you've seen them mentioned, maybe you've heard of them a little bit. And so we're just talking about some very common terms that are that are relevant to know about if you're going to work at any company or any software world. Customer relationship management. So is the process of managing interactions with existing as well as past potential customers. In other words, keeping track of all the customers that have, logged into your website, that have bought items, right? If every store you buy from, they want you to become a member, and then they keep your data for you, who you are, whatever they do with their data, I don't know. It is one of many different approaches that allow a company to manage and analyze its own interactions with its past, current, and potential customers. Because they want to see, am I getting return customers? Am I not getting return customers? Who are my customers? What, how do I going to send advertisements to them based, what kinds of things do they buy there? I want to know trends. I want to know all the information I can about my customers. It uses data analysis about customers' history with the company to improve business relationships with customers, specifically focusing on customer retention and ultimately driving sales growth, right? You want to keep your customers. Go to a different room. One important aspect of the CRM approach is the systems of CRM compile. What? Is the systems of CRM compile data from a range of different communication channels. In other words, they integrate lots of different things, including a company's website, telephone, email, live chat, marketing materials, social media. Throughout the CRM approach and the systems used to facilitate it, businesses learn more about their target audience. So CRM is, goes pretty much with social media. If you have a social media person who wants to keep track of, goes with social media, but also with everything else. But CRM is for maintaining information about your customers, as opposed to ERP, which is about your business. Okay. Now, all right, we're almost done with this, and then I'm going to go to something else. Okay. Four plus one architectural view model. 4+1 is a view model used for describing the architecture of software-intensive systems based on the use of multiple concurrent views. The views are used to describe the system from the viewpoint of different stakeholders, such as, viewing it from the viewpoint of an end user, a developer, a system engineer, a manager. The four views of the model are logical, development, process, and physical. So, okay, in addition, selected use cases or scenarios are used to illustrate the architecture serving as the +1 view. So we have a logical view. The logical view of your system is concerned with the functionality that the system provides to end users. UML diagrams are used to represent the logical view and include class diagrams and state diagrams. Okay, so we're going to describe what functionality the system is. The process view. The process view deals with the dynamic aspects of the system, explains the system processes and how they communicate, and focuses on the runtime behavior of the system. That's kind of like what we saw with the activity diagram. The process view addresses concurrent distributed integrator performance and scalability. UML diagrams to represent process view include the sequence diagram, the communication diagram, the activity diagram. Okay, so these are different views. See, we're saying that these diagrams that that we've seen give different views of the same system. Now, what do I mean? Can anybody tell me what scalability is?
In what regards?
Well, an operator, how can a piece of software, how can I say a system, software system, what does it mean that it's scalable?
It means that when you add, I guess, as you add more users to the system, it retains its functionality, or the slowdown is, I suppose, linear maybe, as opposed to, some other like exponential or something.
I would say not users. I would change one word, what you said. As you add more resources to the system works better. It can handle more people. If you had a system that no matter how many more servers you added to it, it still could only handle 100 users, then it's not scalable. Scalable means as you add more resources, it's now able to handle a larger thing. So I was talking with a friend of mine who was a former student of mine. He was describing for me a job interview question that he would ask people. He says, let's say you have a server that's running, oh, let me see if I can, yeah. Let's say you have a server that's running your web server. And you have a database server that's running the database that the web server interacts with. So you have two servers, database and a web server. And you're selling t-shirts on your website. And now all of a sudden the CEO of your company is going on I don't know, the Colbert or whatever, some TV show to talk about your great t-shirt company. So you know that for the next 48 hours, you're going to get a lot more clients coming to your website. So what would you do to prepare for that? That's his interview question. What would you do to prepare for that? So what would you do? This is a question of scalability. How would you scale up your system? Yitz, you over there?
Allow for more traffic on the website.
Yeah, how would I do that? Exactly. How would I do that?
I don't know. Add more ports that can connect to the server. Maybe it's a physical hardware.
It's a load balancing question. One of those load balancing things that I've been hearing so much about.
Physical problem. You
Yeah, load
only have a
balancing. Yeah.
certain
So
amount of
how?
ports.
First of all, in order to talk about load balancing, then you're assuming that you're going to add more servers. So let's start with that. What are you going to do? You're going to add another database. You're going to add 2 more web servers.
A very open-ended question.
Should you have like a cache
Yeah,
process where you save certain, I'm not sure, certain queries or
Well, what
things?
would be the problem? Let's start with this. What would be the problem you'd face if you just added another database? Another database
What do
server?
you do with the
Duplicate.
database after? What do you do with this database after you're done with all this traffic? All right, is the traffic going to stay at this amount? Is it going to be
Well, let's
worth
think
it?
about. Wait, stop for a second. Let's think about it.
Got to get your money first. You got to ask the money question. Is
No,
it worth
that's not my direction. My direction is not. I want to scale up. Sorry, forget 48 hours. I want to. Yeah, I mean, I want to scale up, and the point is, I want to change my architecture to be able to scale up. What's wrong with my architecture? Let's say I add 2 servers. Let's say I add 2 web servers, and I have a load balancer. So 50% of the time you come, you'll get this web server, and 50% you get the other web server. Have you ever heard of a thing called session data?
Maybe.
Session data is the fact that the web server, it used to be that when I go to Amazon and I put 3 things in my cart, and then I come back a day later, the 3 things are still in my cart. How does that work? Or not a day later. I come back an hour later. I go away from Amazon. I take it back. I go away from Amazon and I watch a movie on YouTube. And now I come back to Amazon and it still has my 3 things in my cart. So I come back to the page and it's immediately there. Now,
right. So back in the good old days, they would have a server where they stored your information. They stored your cart, but then at some point they decided to use cookies to store, so that you are responsible to hold your cart.
No,
browser
quite the opposite. Quite the opposite. In the old days, they use cookies.
Okay.
In the old days, they use cookies for that. But what's the problem with cookies?
You have to store it on your server side.
What if you go to Amazon now on your phone?
Okay.
You don't have it.
You don't have it. It's on you don't have, but I want to, that's not the way it works now. If I put something in my shopping cart on my laptop, and then I go on my phone, I'll see it there too. How does
Are
that?
you
So that means it
logging
can't be
in?
on the cookies, which is client side. It's on the server. If it's on the
All the
server, now that means that's called session data. It's related to my session. I mean, by the way, that session data may not be that may not be the best example of session data. The cart may be actually stored in a database, but session data could also be things like,
preferences and whatnot.
yeah, what my last search was or something like that. If I want to see what my last search was, you know, we're going to redo a previous search. I don't know, other information. It could be preferences. Yeah. So session data. Where are you going to store it? So 50% of the time I go to this server, 50% I go to the other server. So what if I went in on one server and then I came on my phone and I got by chance the other server? I'm not going to have
a
it.
separate database server that just handles retrieval of your information.
So right, I need to put sessions on a session database. In other words, if I'm going to multiply my web servers, I need to decouple the service called providing sessions from the web server, so that as I expand, so that I can have now as many web servers as I want, and they'll all access the same session server to get session. Every time I change something about my session, they'll update that server, and every time I log in, every time I come back to the page, they'll re-grab whatever data is in that server. So whoever, it doesn't matter which server I go to, I'll always get the session data. So that would be one thing you'd need to do. You need to separate out the session data from the web server. And you see that this can go on forever. And as we can continue thinking about information and realizing that it needs to be all decoupled. Basically, we're going to want to have a situation at the end of the day where we have many, many servers, each one doing one thing. And the web server will get whatever it needs. What about the database? So we have also a problem with the database. If we just simply have two databases, so we'll run into other problems. We all of a sudden double our number of our databases. Each database says we have 4 t-shirts, 4 Donald Trump t-shirts. So now we have 8. Can't just reproduce your database. You'll think you have twice as much inventory as you really do. So you have to have some kind of relationship between the databases all of a sudden. You can have what's called a master client relationship, where you have one master database and then databases that serve that get information from the master. And then you can have multiple databases. So you see, it's not just going to be what I had before. What I had before was just one database that was it, and one web server which had the sessions and whatever other things. I can't think of another example right now, but there probably are other examples. So basically, I need to have a different architecture, system architecture. That's what I'm saying. That's scalability. That's called, I need to make my architecture scalable so that I can add. Now, once I have a master client in my databases, I can add as many clients as I want. Of course, I'm still going to have a bottleneck with the master. I can have mirroring. There's different kinds of databases. This is a major subject of people pay a lot of money for database hardware that is capable of fast mirroring, because if I remove one t-shirt from one place, maybe it didn't get removed from the master yet. How long does the master know? Or if it's not master, it could be mirroring, where each one is essentially the master. But a minute I change one, the other one changes. So it has to be pretty fast, because I don't want a situation where I have to have some kind of lock, some kind of semaphores to prevent somebody from buying the same t-shirt. I only have one left. and one mirror removes it, the other one better remove it pretty quick. Okay. So we have the logical view, the process view, we have the development view. The development view illustrates a system from a programmer's perspective and is concerned with software management. This view is also known as the implementation view, uses UML component diagrams to describe system components. UML diagrams used to represent the development view include package diagrams. So that's very interesting. You see, according to this, the development view is not the same as, you know, the state diagrams and the UML. Because the programmer, you know, that's not specific enough for the programmer. He needs these things called component diagrams. Then there's the physical view. The physical view depicts the system from a system engineer's point of view. It is concerned with the topology of the software components on the physical layer, as well as the physical connection between these components. This view is also known as the deployment view. In other words, how many servers do I have? What does each server do? You know, the physical, where is the database kept? How many databases do I have? That's like a physical view. Then you have scenarios. The description of the architecture is illustrated using a small set of use cases or scenarios, which become a fifth view. The scenarios, so that's our use cases, describe sequences or interactions between objects and processes. They are used to identify architectural elements to illustrate and validate architectural design. They also serve as a starting point for a test of architecture prototype. This view is also known as the use case view. So that's like the most basic question: how do I view, or how do I use my system? The 4+1 view model is generic and is not restricted to any notation, tool, design method. In other words, you don't have to use UML. Okay. This is a book, Architectural Blueprints, the 4+1 view model of software architecture. So you see, I'm really trying to say something that's a whole book in a few words. See slides from Engineering Software Products. Skip to slides chapter 4 and 5. That's my note to myself.
Is it possible to break for like 15 minutes?
Yeah, let's break for 15 minutes. We'll come back at 4:15.